You lock your door. You check it twice, maybe. You turn off the lights, get into bed, and fall asleep without one single thought that something might be waiting outside to eat you. Your biggest worry tonight is probably a bad dream, not a set of jaws. For most of human history, that kind of certainty would have sounded insane. For millions of years, your ancestors did not get to assume they'd wake up. They were not at the top of the food chain, not close to it. They were dinner. You'd think evolution eventually just fixed that. Bigger brains, sharper spears, problem solved. That's not what happened. Plenty of animals living under that exact same pressure didn't make it. Mammoths didn't. Giant ground sloths didn't. An entire branch of saber-toothed cats didn't. So how did a slow, clawless, mostly harmless animal not just disappear like every other easy meal in history? It wasn't one lucky break. It was 5 separate tricks, stacking on top of each other, because on their own, none of them were enough. Start with the proof, because this isn't guesswork. Were we actually eaten, or is that just a scary campfire story? In 1924, anatomist Raymond Dart pulled a fossil skull out of a limestone quarry in South Africa. It became known as the Taung child. It belonged to a 2.8 million-year-old Australopithecus, one of our early ancestors, probably no more than 3 or 4 years old when it died. For decades, nobody could explain the strange puncture marks and gouges around its eye sockets. Some assumed a fall. Some assumed nothing at all. Then, starting in 1995, researchers Lee Berger and Ron Clark took a much closer look and matched the damage to something else entirely: talon marks. Punctures consistent with a large bird of prey killing and eating the skull, the same way a modern crowned eagle still does to monkeys today, dropping the skull once it was picked clean. Not attacked by something on the ground, carried off from above, eaten. And it's not an isolated case. At a site called Swartkrans, also in South Africa, anthropologist C.K. Brain examined a hominin skull with 2 puncture holes in the crown. He matched the spacing exactly to the lower canine teeth of a fossil leopard jaw found in the very same layer of rock. 2 holes, 1 bite, 1 predator, identified 2 million years after the fact, purely from geometry. Brain literally titled his resulting research paper, "The Hunters or the Hunted." For a long stretch of our history, the honest answer was the second one. So why aren't we extinct? The first answer isn't a weapon. It's your eyes. Primates, including us, evolved a kind of color vision most mammals don't have: full trichromatic vision, tuned specifically to pick out subtle reds and greens against green foliage. In 2006, biologist Lynn Isbell proposed why. It wasn't for spotting fruit, it was for spotting snakes. A camouflaged predator holding dead still is nearly invisible to most mammal vision, but our ancestors' brains built entire dedicated pathways just for catching that one wrong shape in the leaves before it struck. You still have that circuitry, and it fires embarrassingly fast. In 2008, researchers Vanessa LeBeau and Judy DeLoach ran an experiment on toddlers as young as 3, none of whom had ever been taught what a snake even was. Every one of them picked a snake out of a grid of photos faster than they picked out a frog, a caterpillar, or a flower. Nobody trained that reflex into them. It came pre-installed. It's the same reason a coiled garden hose can make your heart jump half a second before your brain catches up and tells you to relax. Not every biologist agrees on exactly how much of our vision evolved for this one purpose. Fruit finding almost certainly mattered too, and the 2 pressures probably reinforced each other rather than competing. But nobody disputes that the reflex is real, or that it shows up before a toddler can even talk. A predator ambush was clearly a strong enough pressure to help wire a brain around it. The second answer is fire, and not for cooking, for guarding. At Wonderwork Cave in South Africa, a 2012 study led by archaeologist Francesco Berna analyzed ash and burned bone dated to roughly 1 million years ago. It found something the earlier fire use claims hadn't nailed down: burn patterns that couldn't be explained by a wildfire wandering through on its own. This was fire made and kept at the mouth of a cave, on purpose. And a fire at the mouth of a cave does something almost every nocturnal predator respects. It keeps them out. For the first time in a very long time, sleep stopped being the most dangerous 8 hours of the day. Some modern hunter-gatherer groups still keep a fire burning through the night for exactly this reason, in places with no predator threat that particular night. Old habits, apparently, don't need fresh daily proof to stick around.
The third answer is each other. What actually beats a leopard that a single human never could? A predator picking off a lone straggler is efficient. A predator trying to get past 30 pairs of eyes, all facing outward, taking turns on watch, is a much worse bet. We didn't invent the warning system from nothing either. Researchers Robert Seyfarth and Dorothy Cheney spent years in the 1980s recording vervet monkeys in Kenya, and they found something remarkable. The monkeys use a completely different alarm call for every different predator. One bark for an eagle overhead sends everyone diving into the bushes. A different chirp entirely for a leopard on the ground sends them straight up a tree instead. Different threat, different word, correct response, every time. Our ancestors likely started from exactly that kind of system, then built language on top of it. And the math behind it isn't a modern idea either. Back in 1971, biologist W.D. Hamilton worked out something called selfish herd theory. In a crowd, every individual is mostly just trying to put someone else's body between itself and the predator. It sounds cynical. It's also exactly why herding works. A predator facing one exposed target has an easy decision. A predator facing 30 overlapping bodies, all shifting position, all watching a different direction, has to solve a moving puzzle before it even picks a target. Sleeping in groups, posting lookouts, and shouting a specific warning faster than any predator can close the distance turned a soft, slow, clawless animal into a genuinely hard target. Safety in numbers isn't a metaphor here. It's math. A leopard actually has to solve. The fourth answer is the one you'd expect, but it came late. Later than fire, later than vision, later than group living. Sharpened wood, thrown stones, and eventually coordinated ambush hunts didn't just get us food. They meant a predator sizing up a band of maybe 25 to 50 people was no longer looking at easy prey. It was looking at something that might fight back, in numbers, and win. We know how close that fight actually got. In 1995, researchers Thomas Berger and Eric Trinkhaus studied the skeletons of Neanderthals across dozens of sites and found a pattern of healed fractures concentrated almost entirely in the head, neck, and upper body. The injury pattern looked so specific that they compared it to modern rodeo riders, people who make a living getting slammed by something much bigger than them at close range over and over, and mostly surviving. That's not what you get from falling off a rock. That's what you get from grappling with something that fights back at arm's length and walking away from it often enough to heal. A modern self-defense class teaches you to run. Our ancestors didn't get that luxury. There was rarely anywhere to run to that didn't have its own set of teeth waiting in it. There's one more layer, and I saved it for the end, because it's the one that should actually unsettle you a little. So what happened to the predator that used to hunt us back? Somewhere around 1.5 million years ago, a genus of saber-toothed cat called Dinofelis starts vanishing from the fossil record in Africa. Right around the same time, hominin tool use and group hunting really take off.
It was built roughly like a lion, with two long curved fangs and an ambush style built for close, sudden kills. It wasn't small, it wasn't slow. And for a long time, it was one of the animals leaving bite marks on hominin bones in caves like Swartkrans. Researchers have debated for decades whether Dinofelis specialized in hunting our ancestors specifically, the way a modern leopard sometimes specializes in one prey animal over another. Nobody's fully settled it, but the timing is hard to ignore. The predator that may have hunted us generation after generation is gone. We're not. And it didn't stop with Dinofelis. It's still happening now, just slower. Wild lion populations across Africa have collapsed by an estimated 40% or more over the last few decades, mostly because of exactly the same pressure that ended Dinofelis, an increasingly organized, increasingly armed species that no longer tolerates being on the losing end of that relationship. You didn't just outlast the thing that used to hunt you. Your entire lineage has spent the last 2 million years slowly making sure nothing else gets to either. So think about that the next time you feel a flicker of fear in the dark, hearing a noise you can't place. Why does your chest tighten before your brain even tells you what's wrong? That feeling is not a malfunction. It's a 2 million-year-old alarm system, built by ancestors who needed it every single day to survive being someone's meal.
There's one question I keep coming back to. If you'd been born back then, with no fire, no group, and no weapon, using nothing but the body you actually have right now, how long do you think you'd have actually lasted out there? You are not the strongest animal that ever lived. You're not the fastest, and you were never the biggest. You don't have claws, you don't have fangs, and your skin tears if a house cat gets annoyed with you. None of that changed. What changed is that everything which used to hunt you specifically, that used to look at you the way you look at a sandwich, is gone, extinct, or hiding in a shrinking patch of forest somewhere far from your house. Which is the only reason locking one door, one time, actually works. If stories like this, the ones about what almost erased us and why it didn't, are the kind of thing you want more of, subscribe. There's more of this coming.